welcome to everybody to my first webinar for PMI. Glad that you could join us today, and I hope you're all happy PMI rope users and you worn them out so much you're ready to know all about how to inspect them and retire them. So without further ado, I'll move on along with the first slide. And the point of this whole talk is to assume that all of you have already made the correct choice and you know what rope you wanted. There's a whole nother easily 45-minute talk I could give on just how to select a rope, and we can do that one someday. But I'm hoping at this point all of you are rope owners and have made the right choice for the appropriate rope, and you're happy with that, and you just want to know what to do next. So that's what this is all about. I know this is probably a pretty crazy concept for most of us out there, but the first thing I strongly suggest is people to read the instructions. There's a good bit of effort gone into writing our instructions, and I know that you need a magnifying glass maybe to read all of it, but there's a lot out there of information in that little rope booklet that comes with the rope, and strongly suggest that you read them and prepare them and store them for future reference. Assuming you've gotten the box open and you've inspected the rope for obvious things which you should do when you open a box, like look for where the forklift forks smashed through the box or where somebody spilled something on the box while it was in transit. It went in clean and nice when we shipped it to you, but we have no way of knowing what happened once it leaves our door, so it's kind of up to the user to take a look at that and make sure that it still looks nice and neat and clean. We actually have had spools with forks driven to them from forklifts and stuff like that, and you need to be careful to inspect it for visually when you first open it. The next thing is to grab a broom handle is what I use, or a pole of some kind, a piece of pipe, and you put it between a couple of chairs and spin the rope or unroll the spool, getting the rope off of it in the lateral face. If you take it off the end of the spool by standing the spool up on its end, you will find that you have a kinky rope for a long time, and you'll have to go through some tricks to do it. And once you get those kind of kinks in a rope, the best thing to do is go find something really long and tall that you can hang it out on and let the rope actually hang and unkink. So before you do that, take the advice, unroll it off the spool. Paperwork. Everybody loves paperwork. There's a bunch that comes with the rope. This is a little dated slide from what the NFPA stuff used to be, but it's still the same thing. You've got a rope history card, you've got your instructions, you've got some login to do and keep track of, and those are all important things. We provide this with the ropes when we sell them. I hope all of you are making use of those things in your departments or however you use the rope now, because it's really the best way of knowing a lot about your rope, and as time goes by, is to have hung on to all this information. Key to that is a rope inspection log. It's well worth keeping it, especially if there's more than one person using the rope, and that's true of most of them. If you're a caver and it's your rope and you've been on every trip and you're the only one who's ever climbed on it, it's probably a lot different than someone in the fire service who's got shift work and who knows what the guys did the night before. You know, did they tow somebody's car out of the snowbank with it or what? And having a rope log and people knowing that every time they touch that rope, even to inspect it, they ought to be logging it in, is helpful. And for sure, that's one thing you should do is when you first put it in service is log all this stuff down, where you got it, when you put it in service, who had it first, and then start logging the actual inspections as you do them, if you do them annually or once a month or whatever. Whenever you take it all the way out of the bag and look at from end to end and check it, you should be writing down the inspection. And we'll talk about that actual procedure of how to inspect later. But here's the first thing you ought to do when you unpack a new rope after you've taken that first look at it is record that you did inspect it and it looked in good shape, and get down the purchasing information of what you bought. Every rope should come with either the spool or the box or the hank with the label on it. If it came from PMI, this is what the label looks like. NFPA spells out most of what's on this label now. So other companies' labels might look like this or similar to that. They don't all necessarily have their UPC codes on them, but most of this information is on the label. As of the 2006 edition of 1983, we added this elongation information that you'll see in the upper portion of the label there, where it says elongation at 1.36 kilonewtons, which is 300 pounds. This particular rope has 1.8%, and it gives you the elongation also at 600 and at 1,000. And if you're not aware, if you take those numbers and plot them on a little chart there, you can pretty much get an idea of the elongation curve of a rope and how it's going to elongate at different various loads. Give you a little bit of idea what kind of things are going to happen when you put various loads on your rope. And everybody's rope should have those, all the NFPA ropes. The sport ropes, we don't do this on, but it is on the NFPA ropes. And of course the date. We didn't used to have to do this. PMI's done this anyway, even though it's been only recently added to the NFPA to put open dating on it. We've always had a lot number that has the date built into it, and so we could always tell you what the lot number or the actual date down to the day. And for your information, for those of you who are using PMI ropes, that the reason why that lot number is really important to us is should you ever have a problem, that number even tells us the person who inspected it, what machine it was run on, what day it was run on. Every single rope goes out of PMI has that kind of lot number control on it. It's very key to us ever running down a problem should there be one. Another thing we've started to do recently, and it'll help you in your rope history card fill out, is to put the actual part number on the end of the rope. These labels shown here in this picture. This is an RR, which stands for rescue rope. 125 is 12.5 rope. It's available with that lot number on it, the part number on it, its classifications, and a UPC code, which is the product code, which will bring you back to that part number should you have a scanner and be able to scan UPC codes. Those are now, have been for several years now, labeled on the end of the ropes. If you buy them from the factory, that'll be on one end of the rope. Another marker information, if you don't have the end of the rope and you don't really know when the rope is made and you want to know, you're willing to sacrifice a couple of feet of rope, you can actually chop the rope open and peel the sheath back a little bit, as in this picture, and you can see that there's a marker tape that runs in it, and it'll tell you the year and quarter of manufacture and then what standard it was built to at the time it was made. And in our case, it'll say Pigeon Mountain Industries, Lafayette, Georgia on it, and Underwriters Laboratories. PMI's been using an internal marker tape like this, I would guess for pushing 30 years now. It's only been required in NFPA standard about 20, but you should be able to go back, and all but the very first ropes have this. If you have one from, say, the late 70s or early 80s that you bought from us and you're still in service, shame on you. But we can actually, it'll have a colored thread inside it, and we could probably look it up and tell you what year it was made to if you just told us what color thread was in the rope. Next thing, you've got that card all filled out and you know what you're doing is what to do with the rope itself. And I think these are the do's and don'ts of how to take care of your rope. These are the things that all will damage a rope, and I think everybody knows these, but I'm going to run through them just to be sure that we go back over this stuff. The abrasion obviously is the one that most of us experience day to day when we're out there using the rope, and it can be anywhere from a very little abrasion to a lot of abrasion and damage the rope or just barely break it in. And we'll talk about that later too. Heat's another one that we really want to try to avoid. The extreme heat for sure will melt the rope, and medium heat, we'll get into these temperatures later, will actually lessen the strength of it. Chemicals is the scariest one for me because it is possible to chemically damage a rope with something like battery acid or battery fumes, and it won't be necessarily evident to the user that that's even happened, which is why storing the rope properly is so important, because you just never know what might get spilled or knocked or fumed onto a rope. Ultraviolet light, a lot of people get all up about this and make a big deal out of it. I would say the average customer, this isn't really an issue. If you rig your ropes and leave them out for years, it becomes an issue. But I think you'll actually find that the air that you're breathing around that ultraviolet light is probably harder on the rope than the ultraviolet itself. In early days of nylon and polyester ropes, and I'm talking like right after World War I and into the 50s, there was a significant difference between the nylon and polyester with ultraviolet resistance, but there are now stabilizers in the nylons that we buy for sure that make it to have pretty much the same properties for daylight application, UV, as polyesters or nylons. There's very little difference in that, and you shouldn't store them in the light if you can help it, but it's not going to be the end of the rope. Kermannels have the added advantage of protecting the load-bearing part. The light never gets to the core of the rope, so even if your outer rope is slowly fading out, it shouldn't affect the real strength of the rope. Another important thing that you should consider is the compatibility of the gear you're using to the rope size that you've chosen. This is probably a little late at this point. If you've already bought the rope, you need to make sure that it works with the gear you bought and vice versa. It's obviously descenders and ascenders are all usually pretty specific to a relatively narrow range of rope diameters, and if you've bought 5/8 inch rescue rope and your descenders only work on a maximum of 1/2 inch or 12.5, you're going to have problems with it. Same thing with pulleys and Prusik knots and all of it. They all have a range that they work well with, and it's important to have chosen the correct one. You can squeeze a rope into a pulley sheave that maybe it wasn't meant to. It's not good for the pulley sheave, and it's not good for the rope either. So those are all things that will shorten the life, and also you'll have service problems with the rope or the system you're building. Rope handling do's and don'ts. The next one we got up here is edge protection. This is it's a photo of our new little edge protector we've come out with SMC. It's a pretty handy device, and you can talk to our reps about that later, but it's the big important point of this whole slide is that you really need to protect the rope from the sharp edges. Nice, long, smooth, soft, limestone-y edges might not really damage the rope much. There's certainly caves around here in Georgia that have slots in the rocks from where the ropes have wound through the limestone, but I don't suggest that as a plan for your ropes. You really need to use edge rollers, edge protection of some form or other whenever you're doing it. Another issue is non-moving ropes against a moving rope, and you have the friction issue of cutting ropes just from nylon on nylon type motion. So you need to protect ropes with padding as much as possible. Temperature, said I'd talk about it, here you go. There's a lot of ways to get different high temperature issues. In use, obviously, speed repelling is probably the biggest overheating issue with ropes. People who go really, really fast or lose control of a system, you're going to be able to iron the sheath, so to speak, melt a little bit of the sheath. Usually that heat doesn't ever build up enough to really affect the overall temperature of the core and lower the strength of the rope from those kind of uses, but it's still damaging the outer sheath of the rope, and it's going to make it difficult for doing other things later, especially if you really burn it good or melt it good on the sheath. In storage, certainly it's possible to get in some pretty high temperatures in black cars in the Florida sun. The trunk of a black car in the Florida sun would be probably a good example of some pretty high temperatures. But even those, for most of the ropes we're using, don't exceed the high temperature working limit of the materials that are typically in PMI ropes. Below here on this chart are some examples of temperatures. Polyester, 275, nylon 250. These are not the melting points, but these are when you're starting to affect the strength of the yarns permanently, with strength afterwards. Any temperature below this, they'll regain their strength just fine. And Fahrenheit is the working temperature limit. They actually, for those of you who think they're burn proof, they are kind of burn proof. They just turn to carbon at about 900 degrees, so they don't ever actually catch on fire as much as they just powder up, but they still do just fall apart. And so you've got a much higher range, but it's still a range that you need to worry about if you're talking about escape ropes or something that might be in a extreme fire environment. It's easy to get to temperatures that even Kevlar will disappear at in a flash fire situation. The storing of your ropes, that's a really important thing, as I said before, about chemicals and stuff. We have rope bags. They're probably the easiest, fastest way to store flake a rope back into or stuff a rope back into a bag so it'll pull out easily. Keeps most of the sunlight and dirt and grime of day-to-day storage off of the ropes. It keeps them ready to go. We have all kinds of bags. If you want PVC bags, there are some options to do that. Coated nylon Cordura bags will certainly protect most ropes in most situations. If you can't bag it, or you don't want to bag it, coiling for sure. You need to be able to get the rope to come out of the coil or come out of the bag quickly. So you sure don't want to just pile it all in the corner of the compartment of the truck or something like that. Avoid storing your chemicals. That's I can't say enough about that, of the problems we've had over the years at PMI, where people have had rope failures and stuff like that. The majority of them have been something like battery acid or other chemicals that have got on it and ruined the ropes. No one's ever had a major issue, but we've had some really minor near misses with chemicals getting on ropes, and in each case people said, well, golly, I didn't see that. But yeah, maybe I did get some battery acid on that rope. It does happen. Clean your rope as needed. Dirty rope not only doesn't last as long, but it eats up your gear. We'll go into how to clean it later, but there's definitely it's an important thing before you store the rope that you clean it and dry it and make sure it's in good condition. Air drying it is by far the best way. Don't use heat to dry them out. Nylon will absorb a little bit of water, and it takes longer than you might think to air dry. So let it hang out and get good and dry. If you can, just in a cool place. Doesn't need heat, but let it dry and hang dry if you can. And then store it in a cool, dark, clean place, inside a rope bag, inside your compartment of your truck, or in your, however, basement, wherever you want to store it. Try to keep it up off of concrete. A lot of people don't realize that a little bit of water in concrete can be slightly acidic, and that's not good for the bag or the rope. I ruined the tent floor one year doing that in my own basement. It doesn't take much. Talked about edge protection. It's certainly another important thing. Edge rollers. Match your rope to the job. We need to, once again, if you're in a situation where you need a particular temperature rating or chemical rating, there's a whole bunch of stuff. There's a whole other talk about how to match that up for the job if you're going to be doing rescues in a plant that has a lot of acids around versus a plant that's the average industrial plant, or if you're expecting to have a jumper and you need a dynamic rope. There's all kinds of different decisions you need to make, and it's a whole nother talk. Avoid overloading, for sure. That's easily said, and sometimes it's difficult to do, but there's usually a huge margin in there the way we use these ropes versus their design strength, and overloading without something like a high line or someplace, a big force multiplier like that, it shouldn't be an issue to ever overload a rope. Using it for rescue. Now, if you decide to pull that car out of the snowbank, then all bets are off. It's pretty easy to start overloading ropes, moving things that weigh 5,000 and 10,000 pounds. Avoid stepping on rope. Is it going to break the rope when you step on it, or ruin it for stepping on it once? No. I usually tell people this simply because it can grind dirt and stuff into the rope if you're on a really nasty floor surface. Obviously on a smooth, clean concrete floor, it isn't going to hurt it at all. But you have to know that it's smooth, and you have to know that it's clean before you do it. So it generally shows a disdain for others I think, for others' lives and stuff if you go around stomping on their life safety rope. So just in general, we should avoid doing it. We talked about high temperatures. It shouldn't be a big issue for most of us. They're fine in most ambient conditions that we'll be into, but if you're in the fire service and you're using them in fireground operations, then there are some considerations you need to think about. And then obviously if you're storing them and you live in Phoenix or Orlando, and you need to be thinking about not storing them in the back of a black police car trunk or something like that. And then avoid moving ropes, running stationary on top of stationary ropes or anything stationary. If you've got, Edge Pro that are tied off on webbing or anything, you're going to drop Edge Pro. If you've got a fixed rope with a moving rope running across of it, you're going to saw through that fixed rope. But if none of you have ever practiced this, I would say take an old piece of junk rope and try cutting ropes with it. It's pretty amazing how efficient it is to do that with a stationary rope and a moving rope. Pretty scary. Now we get to the inspection part. What do we actually look for once we've decided that it's time to inspect it? We've had this rope in use for a little while, and it's time to take a look at it. Let's talk about what you do. I think the first thing you need to decide is who's going to do the inspection. Is it just going to be anybody? Is it going to be the new guy on the team, or or should it be someone qualified? And the answer, of course, is it should be a qualified. And what makes them qualified? Well, the first thing is the standard NFPA answer is it's going to be determined by the authority having jurisdiction, the AHJ. That's for those of you that don't speak NFPA, that's basically whoever has the say-so in the matter. Most fire departments is going to be, the chief or someone is going to say these people are authorized to inspect. If it's your team, it's going to probably be the president of the team or some council. If it's you and you own it, then it's you. You are the authority having jurisdiction. I think that whoever is doing the inspections should certainly be trained in something to do with rope access or rescue, so they appreciate that this is someone's life that they're looking at, and they need to be very serious about what they're doing. They should be familiar with the rope manufacturer's instructions, that book we talked about. They should have read it. Wouldn't be bad that they'd been to a class like the one you're having right now. They need to understand, what you're looking for and what you're not looking for. And then certainly the biggest and most important thing is if this person doesn't have the authority to pull it out of service, then he's probably the wrong person and not fits for the job and shouldn't be doing the inspection. And then the question is, what do you do if it doesn't pass? And that, I guess, is the destroy the ropes part of this. And what does that really mean? And you want to make sure that it can't get put back into service. And however you do that, I think is somewhat dependent on what works for you. You can alter it, mark it, chop it up into little pieces. You can, for only $3 a meter, you can send it back to PMI, and we'll be glad to throw it away for you. Just kidding, that's a joke. But seriously, we do have a recycle program, and you can send it to us, and we'll recycle it. Most people don't want to do that because of the cost of freight, but we'd be glad to do it. But either way, you need to make sure that it really is out of service, and it won't go back into service by accident at some point in your department or team or whatever. Once again, after you've finished inspecting them, you need to do all these things. We've talked about that already. Read instructions, unpack rope with care. Is it really the rope it's supposed to be? This would be the same thing with taking it out for inspection today. Is this the rope that the rope card goes with? Is all this stuff right? Is there an ID number, and does it match the card? And then you need to fill out the card and restore it properly. But how to do the actual inspection is what's up next here, and this is the part that takes a little bit of time, but it's not so bad if you do it pretty regularly. You get the hang of this, and I prefer this method, which is that you look at every inch of the rope, that you actually run it through your hands in this this bow method of shuffling the rope and constantly taking a foot or two up into a bow and looking for a continuity and a uniform diameter, and feeling that the bow is uniform too, and that you're actually looking for damage, looking for discoloration, looking at everything. Every PMI rope, when it's at the factory, goes out the door, it's run through somebody's hands as it's wound, and we think you should do that over and over again as you do that, and look at every inch of the rope. Every time you deploy it, every time you de-rig it would be great. If you can't do that every time, then you certainly should do it on a regular basis. As I said, you're looking for discoloration of fibers, any kind of indication of a chemical damage. You can smell ropes. Sometimes you'll smell things on them, chemical damage or contamination. You can smell gasoline. Gasoline itself doesn't necessarily hurt the rope, but some of the additives in gasoline might. And my suggestion is, if you've soaked one in gasoline for a long time, that you should probably pull it, even though it might not. The gasoline itself may not hurt the rope. No telling what has happened, and it's just not worth it. You want to be looking for abrasion, cuts, nicks. any kind of visible difference in the rope itself. I think you guys get the concept is you just basically are looking for anything that doesn't look like a new rope. Here's an example of the bend in the rope after the core is broken. This is it's the same rope you saw on the last slide. It's actually been pulled on a pull tester until the core snapped. You can see that the sheath still looks kind of good, but it's really obvious. It's got that hourglass look, and it's got this big kink in it, and it's actually hard right there in the spot where the heat from where the core broke. It will never ever surprise you at that point. You'll see it every time if you've got a total core failure inside a rope like this. It's very obvious. So that's another thing you should quite quickly write down, and then I would take that rope out of service instantly should you see that. Here's a close-up of a real hand inspection. That's that loop is maybe a little smaller for the picture than it has to be. You can do it, but if you can take the time to do a small loop like that, you're going to get a better inspection. The smaller the loop and the more you look at it, the better you're going to do it. So when do you inspect the rope? After every use, for sure. Maybe not the second you coil it up, but before you put it back in service, it definitely needs to be inspected. After every time you clean it, you're going to take it out and you're going to drag it around some places, and you're going to dry it, and you're going to hang it somewhere. So for sure, as you're putting it back in the bag, you should be running that visual inspection as you go. If you don't use it at all, I still think you should regularly inspect it. Take it off the truck, take it out, uncoil it or unbag it, and run it from end to end. Who knows? Did somebody use it and not log a problem? Has some animal built a nest in the bag? All kinds of strange things can happen, and it's just going to be a life safety thing that you're going to pull out really quick and use. Or even if you don't need to pull it out really quickly and use, you're going to be really mad if you've hiked to the top of some mountain or gone deep in some cave and find that somebody's chewed through half of your rope as you're getting ready to drop it into your next rappel. Anytime you've got the time to check it before use, like a training operation, I would definitely do a visual inspection at that time. And if you get a chance before emergency use, it never hurts to even inspect it as you're rigging it, even if it's just running through somebody's hands as they lower it off a cliff or down a pit or whatever. Just actually run it through their hands and make sure there's nothing weird feeling about it. You can do that part just by lowering the rope quickly. Here's an example of an hourglass rope. This is another rope that we pulled, and it's a good close-up of when people talk about an hourglass effect of a rope. This is what we mean. It's very obvious. You will see some little bumps sometimes in ropes from tying a knot or something, and that under load it was pulled, and those usually will come quickly out by just massaging the sheath a little bit. This will not come out. You can massage the sheath all day, and this isn't going to go away because the core has definitely been compromised inside here, and there's no doubt about this. This is not a bump. This is purely damaged rope right here in this picture. And this is a 7/16 easy bend PMI rope. Give you an example of that. Fuzzy rope. I don't know if you guys think that's fuzzy enough or not. Everybody's got their definition of what fuzzy is. I'd say that's pretty fuzzy, and it's probably time to be thinking of retiring that. Our suggestion is that if you look at the individual picks on the rope, the little squares or the little diamonds, those are picks. And if you look at those picks, the picks have, a yarn thickness themselves. Those are the sheath fibers, and if 50% of one of those is worn through, it's probably time to replace it. If it's just a few on the front or the top surface of it, then it's fine. Just keep on using it. But this is probably beyond that point at the point where and notice that it's not consistent. It's badly worn in a couple of sides of the rope, and other sides aren't. This is indicative of something slid, and the rope was running flat and across something really sharp, and it just kind of chewed it up. So here's two really good examples. The lower rope, to me, it's got just what I call the peach fuzz effect. It has just a few broken fibers, and actually those few broken fibers are no longer under tension, and they'll probably stay like that and be a good protective coating on the rope. The one on the top, it's starting to get beat up pretty bad, and it's time to replace it just from the length and the amount of yarns that are broken through now. So when do you actually retire the rope? I think this is what most people always want to know, is when should I retire my rope? And unfortunately, if you're coming for a black and white answer, you're not going to get it, so you can just drop out now if you want. But I'm going to come close to a black and white answer, hopefully, for you. If you suspect the rope strength has been compromised during use, and that's basically anything that's might have happened to it, where you severely overloaded it, or it got a really big shock load, or you did pull a truck out of the snowbank with it, or anything like that, where you really think you may have gone beyond what's this a reasonable working load on the rope and done something to it or cut it or damaged it. Once again, the abrasion thing we talked about, more than half the thickness of the sheath with the yarns are broken. That's time to retire the rope for sure. If it's been controlled or it's been subjected to uncontrolled or excessive loading, something really big fell on it and it caught it, but you don't really know what the load was, and you think it was a big one, then for sure you should think about retiring it. And the less sure you are about how small the load really was, and can't do the math or figure it out, and you think it was a major chunk of the strength of the rope, then it really needs to be pulled out of service. Most of those things are things you can see happen or see on the rope when you inspect it. And if you've seen those things happen or know that they've happened, or some reports that they've happened, or you can see them on the rope, then you definitely want to retire the rope. The rope's been exposed to fumes or actual contact with chemicals. Sometimes you can't see that, but if you know that that's happened, for sure, that's an instant, pull it. It's just not worth it. Now you're going to ask me what chemicals, and people are going to write me in with a million different chemicals and say, what happens if it's this or that? And the problem is that I don't know all of them. Most of the stuff that we have reports on are individual chemicals. Most people get things on their ropes that are mixes of individual chemicals, and how those things react are really tough. I can tell you what household bleach does, but I can't tell you what 409 does, because I don't know all the ingredients in 409. And household bleach is pretty much one solution, and 409 is a bunch of solutions. I happen to know that 409 doesn't hurt nylon, at least one of the I think there's like 40 different mixes of Formula 409, but that it doesn't seem to hurt it from the testing that we've done, but it happens to be one of the few things that we've seen testing on. There are lots of other chemicals out there that we really don't know. Roofing tar gets on ropes a lot, and people say, well, roofing tar hurt my rope. Well, the answer is, if it's petroleum tar and that's all it is, and no. But I don't know that there are any roofing tar still used in America that don't have all kinds of other things, and they may not have even started off as a petroleum product. There are all kinds of chemicals in there, and I can't tell you what they are or aren't. So if it's just on the outside of the sheath and it's not something that soaks in, it's not such a bad deal. And I don't think you'll hurt it. If it's soaked through the rope, then for sure you want to really think about, or you not think about, you definitely want to take it out. So something like a splash of gasoline as you were doing something like, a teaspoon of gasoline spilled out of your stove on a camping expedition and it fell on the rope, and you quickly, wiped it off and it did soak into the rope, would be really different than a 5-gallon can of gas in the compartment of a truck leaked and soaked into the bottom of the bottom 2/3 of a rope that was coiled up in the bottom thing, and it sat in it for 3 hours and completely soaked through the rope. So there is some difference in what exposed means, but I think the worse the chemical is, the less you need to worry about it and just retire it. Obviously, battery acids from charging batteries and battery acid that falls on it, either one, the fumes or the liquid, are really bad for most ropes. To me, the second bullet point here is probably one of the best ones, and that's just when you have loss of faith in the condition of the rope. If you're even thinking about retiring it, then the chances are you probably should. That means there's a reason in your head that you oughtn't to do it, and if you're going to argue over a couple $100, it's going to be somebody's life on the line. I would say that you've got your parameters wrong for what you're doing. So anytime you're not sure the rope, the rope history hasn't been logged for a couple of years, you don't really know what's been going on with the rope, or you don't know what happened with it last night, I would just retire the rope. Obviously, if you see a true reduction of diameter, like we were talking about, the hourglassing and stuff like that, for sure, take it out of service immediately. And then we get to the age question, and this is the one that could go on for a nice debate for a couple hours probably. And that's, when is a rope too old? We try not to sell you a rope that's more than 2 years old. Most of them are only a few weeks old, but we pull them off the shelves here when they're 2 years from the day they're made. And that's simply because we want you to have a few more years of shelf life for the rope, no matter what. I'd like to tell people that the 5 to 10 year range is where you ought to be thinking about replacing it, just strictly based on age. At 10 years, even if it's been well cared for, it's probably time to be taking it off. And if it's been used, for sure, it should be coming out of service. There's some old studies that people took in service ropes, and the average was like 2% degradation of strength per year. So if you follow that and you've loved this rope and taken good care of it, but if you've used it a lot in 10 years, it's going to be at least 20% from the original breaking strength of it. And I won't say at least, that's probably the average answer to it. If you've kept it hermetically sealed, if you really have a way to hermetically seal your ropes and store them, the shelf life is pretty indefinite. Most of us have no way to hermetically seal our ropes and keep them out of even the air we breathe, and that is an issue. Is that some of the worst stuff around is just out there constantly, in the traffic that we're driving our trucks through and that we're living our lives in. And I don't know what your air is like, and I can't really tell you when to do it, but I tell people to budget for 5 years and be happy if they can afford it, and get the money approved in the 7 to 10 years, and over 10 for sure they need to be replaced. That's my best guess. If in doubt, throw it out. I don't know what else to say about that. That's certainly the best advice of when to toss it. If you're having a discussion, it's time to go. Let's talk briefly about cleaning the ropes. Assuming you've inspected it and decided it's in good shape, you should probably clean it before you inspect it, but either way, here's the first thing again is read the directions, see what it says. If it says dry clean it. We don't have any ropes that you should dry clean, but read what the manufacturer says. Our suggestion is cold water, a mild soap. We have PMI rope soap, which works really great. and it's not a detergent. The detergents cut the oils out of ropes, and there are some oils that are in the yarn normally from the process of the twisting and winding processes and the manufacturing processes, and those yarns actually help keep the ropes flexible. And the more you clean it with hot water and detergents, the less flexible the rope's going to be, just from removing all those little oils that are in there. It's kind of like taking care of your skin. Air dry, not in the sun. Find a shady spot, hang it inside a building, whatever. Air dry, and once again, record it in your rope log. These commercial rope washers, like the PMI rope washer, those of you who've never seen it, it goes on the end of a hose. It's got a piece of astroturf-like material on the inside that scrubs the rope, and the water runs in one end and out the other, and it's really great, especially if you've got a muddy, gritty rope, that it washes the rope really nicely and scrubs it clean. And I strongly suggest that everybody have one of these. If you run into very dirty ropes very often, it's a lot better. You can take a rope to one of these commercial car wash type things with the blasting wand, and it blasts the mud and dirt off the rope, but it also probably blasts a little bit of it inside the rope, and that's not a good thing. It's better to have a brush on the outside and some water to wash it off the brush, like this system works. And in conclusion, using the right rope and taking care of it and inspecting it is really the best way to extend the life of your rope, and it's going to keep you out of trouble. I think you'll avoid a lot of problems by always inspecting your rope and keeping it in good shape. And it's kind of the end of my talk, and I'm going to turn it back over here to Jessica, if I can find the right button. And there you go, Jessica. It's yours. Jess? You out there,
Yes.
Jess?
Yep, sorry about that. Well, we actually didn't receive any questions about that, so Steve, good job. You pretty much covered everything. So we thank you guys for attending, and looks like we're even going to get done a couple minutes early. So if you have any questions, you can feel free to use the link on the page that I showed at the beginning of the webinar right here to, if you use that link, tell me when it's posted, you can send questions. And we look forward to seeing you at our next webinar. Actually, wow, okay, we just got a whole lot of questions actually. Okay, the first one is, Steve, what's your opinion of using mild bleach solutions to remove blood from a rope?
It's actually covered in the PMI instructions, and yes, that's fine unless you're doing it about every day. I don't know the answer to what happens after you've done it 1,000 times. I do know that 20 or 30 times in the life cycle, the rope shouldn't be significant to it. Bleach itself is not great for ropes, but the typical solution that most people in the responding business do, which is a 10% solution of household bleach, which is already diluted to begin with, but a 10% solution of the typical household bleach, which would be 1 part bleach and 9 parts of water, is fine within reason. Like I said, all bets are off if you use way too many of that. But I don't think most of us get blood on our ropes every day, hopefully.
Yeah, let's hope not. Okay, the next one is PMI cooperating with the Northern Kentucky University study regarding appropriate decontamination protocols against white nose syndrome?
Yes, we sent them a whole herd of ropes last summer, and other things besides ropes. We sent them harnesses, accessory cords, webbing, all kinds of stuff. and they've had it ever since last summer. There was a screw up very briefly where they said they didn't find it, but we sent it again. But they've had it for quite a while now. But I don't think you're going to find any difference between anybody's materials. Everybody's using the same, either nylon 6 or 6/6 or polyester material, so it doesn't matter whose rope they've tested. The answers are going to be pretty much the same.
Okay. The next one is, what do you think about yellowing?
Clarification, you're talking about yellowing of a white rope that we made, or something else? I'm not sure if the person could elaborate. That would help.
Yes. Yellowing of a white rope.
Yellowing of a white rope is probably specific to the DuPont 707 cordage finish. That's one of those oils I was telling you that was laid on the outside of the rope. Apparently it reacts with carbon monoxide and gives it that slightly yellow look. Doesn't do anything to the rope. It's just the coating, the lubricity material that's on the outside of the rope. And if it's stored somewhere like a garage or any place where there's occasionally carbon monoxide, it doesn't take much, and the part that's exposed to air will show a little bit of yellowing. That's perfectly okay. It isn't going to hurt anything.
Okay, the next one is, what do you recommend for decon for WNS?
I think kind of answered that in a way that it's a lot. Boy, you could talk about this one for hours. No one really knows what it is completely, what WNS is. They have all these different pieces of it, and they've proven that the spore can be killed with normal decon solutions, and the bleach one doesn't hurt the rope if used in moderation. As I said, if you're doing it every week for the next 10 years, I'm not sure what will happen. The reason I mentioned the Formula 409 earlier in the talk was that I believe that's one of them that Hazel had come up with, is not damaging the ropes and doing a really good job of killing the spore. So if you get basically it's the institutional hospital version of the Formula 409 with the antibacterial agent, I guess it comes in that one, that it seems to do a really good job. And we haven't ourselves tested it, but they've tested it and they say it doesn't hurt the nylon. So like I said, nylon is nylon. It shouldn't make any difference.
Okay. Do you know what type of barcode scanner systems or software are available for logging ropes?
Logging our ropes, anything that will read the UPC, which is Universal Product Code, should work fine on it if it's set up to read which is basically the retail standard for the world. The Universal Product Code. It's a universal registry. The first few digits identified as Pigeon Mountain Industries, and the last digits identified as by part number. And what you have to do is load, ask us for, if you want, we can give you all our part numbers with the UPC numbers that go with them, and then you can just look them up. But anything that will read a UPC code and then look in a table for a match, we can give you the matching numbers for it if you want to use the system. As far as other ways of marking ropes, there's some things people are doing with the newer technology, which is the RFID, the radio frequency identification systems, like you see people putting in the small of the back of dogs to identify their dogs. You can stick one of those inside a rope sheath or a piece of webbing or a harness, anything that's not metal, and run one of these RFID scanners across it, which is I think they're $200 or $300 now to buy a scanner, and it'll tell you what that code is. And some of them read only, some of them read right. There's all kinds of versions of it you can do. You can actually do it where the RFID chip carries the history of the rope and you can write to it, or others it just carries what the product ID number of that you've assigned the rope is, and you can do it. just by reading it open, and you put it into a log, and then you have to type in what happened. But you can get really fancy, and you can have automatic readers that log it every time it goes in and out of the door to your rescue hall, for instance, is one rather utopian concept that but cool and possible to do. It's what Walmart wants to do. They want to put it on everything so that as it walks out the door at Walmart, they know it's left, and they know who got it, and then when you get it home, your refrigerator will recognize it and log it into your refrigerator and tell you that it's stale dated. When it gets to be 2-week-old jug of milk or something, it'll tell you to go buy more milk at Walmart. That's where that technology ought to go, and it exists today, and you could do it. The problem with it, using it for rescue gear, is it doesn't work really well glued to a piece of metal like a pulley side or anything steel. It needs something to isolate it from the metal so that the radio part of the radio frequency ID chip will work. Dogs don't have metal on them, so it works really great in dogs. Probably more than you wanted to know.
Okay, the next one is, what's the best lubricant for hardware that doesn't affect rope?
I usually recommend LPS, which is a product you can buy at most auto parts places. It's what SMC suggests for their carabiners. If that's what we're talking about for hardware lubricant, it's you can use it. It displaces water really nicely. You can. I first used it in the electronics business, but it's great for cleaning gear. It's not sticky, so if you spray it in the springs of carabiner gates and things like that, it doesn't attract dirt to it later, and it does displace water really nicely. In fact, if you got a car that's flooded out, you can spray it in a distributor cap and slam the cap back down, and it'll crank right up. It blows all the water out of or actually removes all the water from the distributor cap. It's pretty cool stuff. It's called LPS. There's a 1, 2, and maybe a 3, and 1 is the lightest weight one, and the one I would use. As far as putting lubricants back into the rope deliberately, if you're talking about the rope getting stiff, that's I hate to go down this road, but you can use fabric rope, but you have to be very careful about that. Too much fabric softener isn't a good thing, but if you do it per the mix rate that they suggest with the product for your average home laundry, it actually helps, keeps the ropes a little bit nicer to handle, and they smell nicer too, which is, I'm sure, important to most of you.
Okay, the next one is, you mentioned taking your rope out of service if it sees a big shock load. Are you referring to a force or a fall factor? Not a particular fall factor, but you could use that to calculate it if you didn't know. But yeah, I'm talking about a force, and I guess they go hand in hand. If you have a high fall factor and a large load at the same time, then yeah, you're going to have a big force. So I don't have a magic number. NFPA limits it to a particular fall factor, mostly because of the damage to the user, not to the rope. I think in the standard we say a 0.25 fall factor is not. It's a maximum that NFPA rescue standard applies to, which is a long way from a dynamic rope, which people are regularly doing, 1.5s and stuff. And even a fall factor 2 isn't bad if it's a body weight. It isn't bad, I should say, on the rope. It's not really great if you're a human being and you're taking a fall factor 2 fall on a static rope. You will really be in pain if you survive. The issue really is what the total force is, measured force, and you have to do the math to figure out how much what the weight was and how far it fell, and see how, is that 10% of the rope strength, or is that 75% of the rope strength? And if it's 75% of the rope strength, then I'd say, I think I'd buy a new rope. Okay, and the last question is, if on inspecting your rope you find a suspect area, do you recommend taking the entire rope out of service or just the damaged section?
Oh boy, it depends on what damaged it. If you know what damaged it and you saw that that was the only thing that was damaged, then I would take that out. If you have no clue what it was, different scenario. But if if you're on a, if you've got it rigged somewhere and somebody knocks a rock off and you see it hit the last 10 feet of the rope and that's the only place it hits, and you later inspect it and golly, there's this big mash spot or nick out of the rope, then sure, I just cut the rope at right above that spot. If there's a huge rock slide and rocks go tumbling down and smash all around everywhere and you don't really know how many times the rope got hit where, and you see a couple of places that it's mashed up, I think I'd just replace the whole rope.
Okay, great. Well, that seems to be all the questions.
Okay. My favorite answer to any of those things usually is it depends on the situation, and that's why the when in doubt, throw it out is there, because you're the one who's standing there looking at it. I can't tell you too much, but if you're not sure, then toss it. Thanks, Jessica. I didn't mean to interrupt you.
No, you're fine. That's great. So if anybody has any other questions, feel free to use the link on the website shown. Says tell me when it's posted. And you can also use that link if you'd like to see a copy of this when it's posted. And we look forward to seeing you at our next one. We're going to be doing these webinars once a month. So our next one will be in April, and just keep an eye out for the announcement for what the topic is. And I hope everyone has a great day. Thanks, Steve, for doing this.
My pleasure.
All right, have a great day, everybody.
Goodbye, everybody. Thanks for coming.